Immunochemistry. This is the branch of chemistry dealing with the reactions and components of the immune system, from the Latin immunis, meaning to exempt. It is all about the cells, the tissues, and molecules that mediate resistance to infections. The heart of this study is about antibody molecules, the immunoglobulin. This science holds the future of biomedical research, and it is geared to discover, develop, and understand the wide range of pathology and emerge with a promising cure to a new advent of medication that will resolve cancer, HIV, and ensure potential prevention and preparation for any future pandemic. In our study of immunochemistry, we will have to revisit immunology, which is the study of structure and function of the immune system. And under that, we will have to talk about the body defenses as the main concept of immunology, which down below is a concept map that will guide us in our study of immunochemistry. Under the body defenses, it is further subdivided into innate and adaptive, from which innate is also known as the non-specific response and adaptive is a specific response. Now, under the innate, there are mechanisms of action from which the body will be defended by the innate system, classified as the following: the skin and the mucous membrane, the inflammation, the natural killer cells, the complement system, the interferon. All of these are intended to fight infections and to facilitate tissue repair as its main goal. Now, under the adaptive, it is further subdivided into two: the humoral and the cell-mediated. Under the humoral, B lymphocyte is the primary actors of humoral response. And the B lymphocytes are further classified into plasma cells and the memory cells. Now, plasma cells are the producer or manufacturer of the B lymphocytes, from which it will afford a short-term immunity as compared with the memory cells that will confer a lifelong immunity. Now, under the cell-mediated, the T lymphocytes is the main actor, from which under the cell-mediated, there will be CD8, and CD8 is known as the cytotoxic T cell. And the CD4, which is also classified as specific to mediators of the T helper cell. The immune system. Some anatomy literature is not cognizant of the immune system. It is often written as the lymphatics and the lymphoid organs. Well, in fact, it is the most complex system of all. The human body is an amazing machine, and the function of the human body is very complex. It's from head to toe. And the immune system is a tough one. That's inside out. Well, human immune system acts as the guardian of health. It is ready to defend, fight, and protect us in times of war. I mean, during the invasion, proliferation, and attack of a hostile pathogens, or what we call the causative agent of diseases and illness. The pathogens. It can either be called as an infectious, etiologic, or a biological agent that causes disease or illness to human body. And for over 100 years, several pathogens were recognized and classified by a clinical researcher. They can either be named as bacteria, the virus, the fungi, the parasite, or the protozoa, they are inescapable and deadly enemies or nemesis of our own body soldier, or we call the immune system. They can either be microscopic or submicroscopic. And one of the deadliest invaders for over the past 80 years is that of the virus. That with our current situation at the time of my speaking and writing, this coronavirus that you're seeing on top as a causative agent of COVID 19 has infected 68 million individuals and increasing in number. And it has claimed 1.5 million deaths and increasing. What you're seeing below is in the middle, you have the bacteriophage. And to your surprise, this bacteriophage can even infect its a bacteria or an archaea and can take over the machinery not only of a cell but even the bacteria. And below is a flu virus. Other than that, the bacteria, these are the microscopic and they constitute the large domain of the prokaryotic and they are the common culprit for most of the diseases. What you're seeing on top is a compounded group of bacteria. In the middle is an E. coli, and below is a Klebsiella. And they have a very infinite number, uncountable number. And parasite, you're seeing a situation called ascariasis. And it's the most common human parasitic infection. And down below are lumbrocoides. Other than that, the protozoa, they're the single-celled eukaryotes. And what you're seeing on top is an amoeba. Down below is a paramecium and euglenia. And the fungi, they are the harmful heterotrophs. And right on top, you're seeing a Candida aureus, the middle as aspergillus, and down below as spores. Now, to sum it up, we may say that there are more pathogens than the stars that we can see at night when we look up in the heaven. And it thrives enormously or unimaginably as the enemies of our body. And there's even a presumption that when all else is gone, or when the earth is gone, these pathogens will still remain. The immune system is a network of biological processes and it protects and defends the human body against invaders or diseases. It is classified under the lymphatic system and lymphoid organs. And these are primarily composed of number one, the bone marrow, where billions of WBC are being manufactured. And the thymus and the spleen is the site where the manufactured WBC will have to rest and mature. And as well, these two are responsible for filtering pathogens. Added to that, the the lymphoid tissues are those structures which can be palpable and can be felt in axillary, the groin, and cervical, and they are scattered all over the body. Where the lymph nodes are responsible for filtering the pathogen before it returns the lymph or the clear fluid back to the venous circulation. And the adenoids and the tonsils are responsible for trapping the pathogen. It uses the antibodies to prevent throat and lung infection. Added to that are the intestine, the Peyer's patches, and the appendix, which are basically the structure of the lower gastrointestinal system. They are masses of tissue and they regulate the bacterial population, prevent the growth of pathogens. Body defenses against infection. Body defenses falls under the concept of immunity, and it best explains the organization of the immune system. It is further divided into the first, second, and third line of defenses. The first and the second line of defenses are classified as non-specific and is innate, from which they are said to have an immediate response. While the third line of defense is said to be specific and is classified as adaptive, and it has a delayed immune response, yet it lasts longer. The first line of defense is composed of a physical and chemical barriers, from which this is being represented by the skin and the mucous membrane that lines the respiratory, gastrointestinal, urinary, and even the reproductive tract. By analogy, the first line of defense may be likened to a great wall that protects the castle from the invaders. The castle being the body, the wall representing the skin, and the invaders being the pathogen that must be prevented from entering. If the pathogens are able to get past or able to penetrate the first line of defense, then the pathogens will have to face and encounter the second line of defense, which is being composed of the phagocytes, the natural killer cell, the inflammation process, the fever, and the antimicrobial substances that may be produced in the process. By analogy, the second line of defense may be comparable or identical to a well orchestrated logistics and an even more powerful armor and ammunition to defeat the enemies that has passed by the first layer of defense. It is also directed for the opponents to yield and succumb to their firefighting power. The third line of defense results from the functional failure of the first and the second line of defenses. It relies on lymphocytes, such as the B and the T lymphocytes, the antibodies, and the macrophages, particularly the neutrophils. Third line of defense has specific qualities. That means it is target oriented. It also have an adaptive quality which can heighten the response by its second exposure via its memory. And again, by analogy, the breach of the kingdom wall and the failure of the ammunition and the logistics will lead to a man-to-man combat, which is highly comparable to the role of the lymphocytes and neutrophils that will lead to a cell-to-cell encounter. The mechanism of innate immunity, the skin. The skin is the primary barrier against physical insult and invasion of pathogen. It provides a unique environment that maintains homeostasis and can induce immune responses. It is composed of the top layer epidermis, the middle dermis, and the bottom subcutaneous fatty region. And on top, the normal flora. Now, epidermis is composed of a highly specialized epidermal cell or epithelial cell known as the keratinocytes, from which it replenishes the cells from the basal keratinocyte that undergoes mitosis frequently. And on top is the corneocytes, a dead layer of cells that serves as a primary barrier of the skin. Now, there are diverse structures that populates the skin, and one of that is the Langerhans cells. It also involves the presence of the dendritic cell and the CD8 T cells. In times of cell injury, chemical substances are being released such as the antimicrobial peptide that delivers the infection and flowing substances that triggers the interleukins and the chemokines, and that they recruit more neutrophils and T cells to kill the infected keratinocytes, and that regulates the healing process that proceeds from their action. And this is the mechanism of the innate immunity provided by the skin. The mechanism of innate immunity, the mucous membrane or the mucosa. It lines or covers the many tracts of the body systems, namely the respiratory, the gastrointestinal, the urinary, and the reproductive tract. The mucous membrane mechanisms of action includes primarily the provision of the physical barrier. As well, it is responsible for the mucose production, and particularly in respiratory system, ciliary action plays an important role. Maintenance of a normal flora is also regulated. The provision of an important acidic environment with a very low pH, and the production of antimicrobial substances. All of this contributes to innate immunity. Let's take a look and listen to a microscopic or a submicroscopic clip of a mucosal dynamics. The mucous membrane or the mucosa lines the various cavities of the body. It covers the surfaces and linings of the many organs or many tracts. It affords protection from harmful external agents by the action of dendritic cell and other related mucus-secreting cell. It is capable of secreting the antimicrobial substances that drives away the pathogens as they are being killed. The ampiregulin is responsible for the maintenance of the damaged epithelial cell, and biomitosis, pathogen clearance, and the growth of the new cells are being produced, as well as the mucus production. Particularly in gastric mucosa, it provides barrier, increases tolerance, pathogenic clearance, and responsible for chronic inflammation.